Yeah, volume over temperature equals K. That's Charles' law. P times V equals K. That's Boyle's law. We rewrite it so that it's easier to solve problems, but that's the basic part. That's the basic beginning of it.
Which one is right?
They're all right. Okay. Well, these K's here, these lowercase letter K's, are constants. This R is also a constant, but it's a special constant and important enough that we give it a special letter.
Is that why we capitalize?
Yeah, part of it, I guess. I didn't make that decision, so I don't know how to tell you. I don't know if I can really answer that question. Okay? But I want you to look on the front page of your test references. Look on the front page of your test references and see what the value of R. Since it's a constant, it doesn't change. What is the value of R?
Universal gas constant. What you mean the value?
Well, what numerical value does it have?
0.80820.
Actually, it has 6 different numerical values.
It has 0.08.
Okay, listen. The only difference, these numbers are the same. The numbers are the same. What's different is the way they're being measured.
They're different. Okay, I see.
Different units of measurement. Okay? Now, I want to give you a little warning here real quick. A lot of students, when they're given a gas law problem, will try to plug in pressure in this fraction. That's not a variable. You can't plug something in for that. These are units of measurement here. They're not variables. You can plug numbers in for these. These are variables. These are not variables. You can plug numbers in here, but you cannot plug numbers in here. Okay? But what you do is you choose the version of R that makes your math easier. Does that make sense? We're going to choose the version of R that makes our math easier. All right, let's start with our gas law problem here. Yes?
What is mmHg stand for?
What is millimeters of mercury?
Yeah.
What it means, that's how high the mercury rises in a tube. And it's a way of measuring. It's a device that you use to measure gas pressure. It's a very accurate way, actually. And it's still used quite a lot. I don't have any pictures over there, but I have some pictures from where I was doing that research at Furman a couple of years ago, where we're using a device like that, where the mercury actually rises up and you look at it and measure where it comes to. Yeah. All right. Sure. But only if you can smile for me. She just ain't gonna do it. She's so hard-headed. God. Please write this down as I write it.
You come with these on top of your head?
Pretty much.
You gotta write all this, or should we just write the number down?
Write it all down. Yeah, and once you finish this, start making out your list of knowns and unknowns. Yes.
When you said the second, yesterday was that test in there or no?
No.
Okay, but on an error tomorrow will be.
Yes.
Okay, so if you do a pre-test before tomorrow, can you change the grade?
You mean the makeup test?
Yes.
If I can work in the time to actually grade it, sure. Or I can, if you come out to school tomorrow and I can grade it, I can print a new one out or something, sure.
You have to do this both ways.
Both ways what?
You have to do V over T.
No, I want you to just write down your list of knowns and unknowns right now.
Find out that if there was anything in there that you hadn't put in yet.
Yeah, that's what one of the reasons I came in early to put in a couple other things, and my computer was dead this morning, so there'll be a couple more quiz or homework grades or something. I forget what they are.
Would this formula like which you would
Very good. Yeah, but let's just write down what you can from the problem. And that's what I'm actually going to cover here next. That's what I put down here for. Put this down this way for. Very insightful. Good for you.
I think she was there for you kids.
I heard you.
You should reward us like every time we do something good, give us this cane.
So you tripping.
You did that.
I should, huh? Okay.
Yeah, they be like, oh, your words be better than the text words. That's all. Now, can you give us our homework, bro?
It will be easy.
All right. What do I need to do with this?
Oh, you got to enter the Kelvin.
Okay.
73.15.
Okay. You get the correct answer if you do it correctly.
Oh,
True.
If I get trick out, 273.15?
Yeah.
Is it 273.15? It's the Kelvin thing. Plus,
25 plus 273.15 is 300 and something?
Now that's
Wait.
Yeah.
298.15.
298 point, yeah.
No, it's point two. It's point two because you got to round it up. It's point two. Now it's point two.
You got to round it up.
Round it up to what?
Piece of candy, me.
Man, I knew 273 in my head.
How you do
That's
this?
PCM myself.
You want to know how to do that math? Is that what you're saying, Brandon? All you got to do is add the 25.0 to 273.15 and round off properly. Okay? All right. Now, what about the unknown? What kind of symbol are we going to have for that?
Question mark.
What symbol do we use for that?
Gas. This N, because you don't know that.
Yes, it's the amount of gas. N is how we measure it in moles, okay? So that's right. All right, now, so we got V, P, T, and N. Let's look at our list of gas laws over here. Get out your test references and follow along with me if you would, please. Okay? So here's all our gas laws. Let me move that up a little bit and we can maybe see both at one time. Okay? All right, so we got V, P, T, and N. If I'm looking through here, I can see, well, hey, there's one that's just about like it. The only thing I'm missing is R. But you always have R. R is always there. Okay? It's on your test references. We just have to figure out which one to use. Well, here's how you do that. Let's go back over here to the front page of your test references. Okay? Here's the front page of the test references with those 6 different versions of R. All I have to do is to find a version of R that matches the units of measurement in the problem. The very first one has liters, like liters here, has atmospheres, like atmospheres here, has Kelvin, like our temperature here, and has moles, like N represents. So that's the version of R I need. Now, just as a little hint, about the only thing that's going to change in here is going to be your pressure units. We're really not going to use these two versions of R over here in the lower left. We're going to use these right here. Okay? So if you just match up the pressure units, atmosphere, millimeters of mercury, kilopascals, or torr, as long as those match up, everything else is going to work out for you. Okay? So we need that version of R. We'll write it out here, 0.08206 liters times atmospheres over Kelvin times moles. All right, now we're ready to start the problem solution process. We made our list of knowns and unknowns, and we always know R is there. Now, you don't have to write it down if you're doing a Charles law problem or a Boyle's law problem or a combined gas law problem. But if you're doing a ideal gas law problem like this, okay, then I had a Herman Cain moment there. Gas law problems like this, then you're going to have you have to find out what R is and match it to your units of measurement. Yeah, if somebody's listening to this later on, you might not realize that this is in the middle of a presidential election cycle, and there's a big story going on right now about Herman Cain, kind of going blank for about 10 seconds. Well, I do that all the time, so can't hold that against him, right?
Everybody should get that on the floor.
Huh? Okay. All right, so the equation we're going to need is PV equals nRT. Okay. You want to give you a helpful hint here?
What's up?
You want a helpful hint?
Yeah, what's up?
Okay. This is going to be one of those kind of problems where you're probably going to want to get some white paper and turn it the long way, not the short way. Okay? So in fact, why don't I just kind of raise this camera up a little bit, and I'll show you why that works out that way. So you can see this whole long piece of paper. Okay? All right. I'm going to put it back down here. I'm just trying to set the paper out. All right. I'm going to transfer this PV equals nRT onto this paper here. All right. So now that we've got our list of knowns and unknowns, and now that we've got our equation here, we can start plugging values into that equation. Okay? So P is 1.05 atmospheres. V is 0.25 liters. N, we don't know, so we're going to leave that on there just like that. R is 0.08206 liters times atmospheres over Kelvin times moles. And T is 298.2 K. All right. The next step, since we plugged in our knowns, the next step is to get N by itself. What do I need to do this side of the equation to get N by itself?
You gotta multiply first 298. No 1 over 298.
Okay, basically I got to multiply by the reciprocal of both these fractions.
Yeah.
Well, I'm going to show you over here why you need to multiply by the reciprocal.
You need to break into it.
Alright, so we want Kelvin times moles over 0.08206 liters times atmospheres. And then I need to multiply by the reciprocal of this, 1 over 298.2 K. I don't have a lot of room over here, so I'm kind of squeezing it up a bit. But these two are the reciprocals of that. Remember what I do to this side, I have to do to this side, right? All right, so I need 1 over 298.2K. That's the reciprocal of this one. That's the same thing as that. I know. It's kind of small, but just follow along what we're doing. Okay? You can read that part on your own paper. And you know you got to flip it over. So we're going to multiply by the reciprocal. I mean, this as well. So since I multiplied this side by these two things, I got to multiply this side by those same two things. So I plug this one in right here. Now I can plug this one in right here. That's Kelvin times moles over 0.08206 liters times atmospheres. 298.2K. Right, same as right here. Wait a minute, where is it? There it is.
And that whole side cancel out.
This whole side will cancel out.
Except the end.
Yep, which is what we want. So I got 0.08206 liters times atmospheres on here, and I've got the same thing down here, so those can cancel. Kelvins times moles. Kelvins times moles cancels. 298.2K. Top and bottom, those cancel. Okay? So all I've got N by itself over here then. Alright, now over here, we've got to do a little bit of work with this one. Let's put this over 1, because it doesn't change the value when you put it over 1. It just makes it a little easier for us to set up this problem by doing that, okay? But when I do that, I can see clearly now, I hope. I can see clearly now. Oh well. Alright. Atmospheres cancels atmospheres. Liters cancels liters. Kelvin cancels Kelvin. I'm left with moles. And what are we looking for? Amount of a substance. Moles measures the amount of a substance. Okay? So I know I've probably done the math right. Or done the setup right anyway. Now I'm ready to plug the math in the calculator. Alright, 1.05 times 0.25. Oop, I got to turn it on first. 1.05 times 0.25. Hit enter. Then I'm going to divide, hit divide, put in this number, 0.08206. Okay, I'm going to hit enter, and then divide again to put in this number, 298.2, and hit enter. Okay.
What's on the right side of the calculator cover?
Oh, and pull it down a little bit.
Is it? Sorry, I see the 298.2K over 1. What's after this? K moles over 0.
Oh, Kelvin moles over 0.08206 liters per atmosphere. Liters times atmospheres. Same as this one right here. Okay. Alright, so the number we got here is 0.017272933. The only unit we have left is moles. Moles measures the amount of substance, and N is the symbol we use for the amount of substance. Okay? Got around it. How many digits do I need in my final answer?
3.
2.
Oh, 2, yeah.
Okay, got to look carefully. Okay, so we underline everything after the first two significant digits. These 2 zeros are not significant. Leading zeros are not significant. They're leading because they're on the left, the way we read, left to right. Okay? So this is our first significant digit, and this 0 is significant because it follows a decimal place and a non-zero digit, and because it's between two significant digits. So we're going to underline everything after the first two significant digits because we're going to round them off. Draw an arrow. 0.011 moles equals N.
Or the amount of gas in moles.
That's the amount of gas that Chelsea has in her Ziploc bag.
It's one, every stuff.
Yeah.
All the way on the other side, it's 1 over what?
Right here?
No, 1 over 290.
Over here? 1 over 298.2K. Hmm? If you need to go to the bathroom, I guess you can. Huh? Yeah, we almost got time here. By the time he comes back, I don't know if you're going to need to go. Huh? I don't know how long you're going to take. Really? All right, let's write down a quick homework problem for you to work on.
In our packet?
Oh,
That boy is here to CO2. What is it? COR.
CJ exhales 275.6 moles of CO2 in 1/4 of the Gaffney game. If the pressure is 761.1 torr,
COR.
T-O-R-R, and the temperature is 15.1 degrees C, what's the volume?
What is it for?
One of the pressure units. Okay? And it says the pressure, okay? So there's torr listed on that front page there with other pressure units. Okay, what?
Was that 761.1?
761.1.